Welcome back. Today I'm going to have a look at a Trio DL703 digital multimeter that I picked up a little while back. Don't know much about it other than it doesn't work properly. So let's dive on in. Several months ago I picked up this DL703 digital multimeter that had been tossed in e-waste. I found an advertisement for these units in a 1976 edition of Electronics Australia. $120 back then, or about 840 of today's Australian dollars. It seems these were considered the step up from analog meters, giving 3.5 digits at 0.3% accuracy. This one's a little bit unhappy though. If I turn it on, the display just settles at a constant value and it doesn't change, even if I try and coax it into changing by feeding it some input. So let's pop the lid and see what's going on inside. Well, the first order of business is going to be to unplug it from the mains, because I don't want to get zapped. Right, and I think the bottom will probably come off as well. Right, so she's a relatively retro construction, as you'd expect. This looks like the board where we do the adjustments. Actually, before we do that, let's just check that we're getting various voltages around the board. So I'll plug the mains back in. Remember that this is live now, and we should be getting some voltages around the place. So what do we got? Somewhere around here we get plus 12. Not there. Don't know how well positioned these are. Yeah, there we go. So there's 12 volts, so 11.7, so that looks okay. Is that 5? Yeah, 4.57, it's I guess slightly low, but could be worse. That's AC, so we'll get to that in a minute. I think there's 12 volts as well, yep. Minus 12 in here somewhere. Minus 8. Where is this minus? There we go, there's our minus 12. So that track there is the minus 12, and that's 11.5, so it could be slightly higher, but it's okay. Let's just check the AC voltages. So we should have 15 volts here apparently. Okay, why are we getting 20? What have we got? Oh, okay. So yeah, 15. Yeah, so that's about right. And looks like we should be getting 8 up here. Oh, okay. And 7.6. So the voltages are slightly low, but I don't think that's going to be the problem. Just unplug it from the mains again. Leave the cord where I can see it so I know it's unplugged. So I think I'll pop this board out so we can see what's going on underneath. That's going to be a bit of a pest. Find a bit of tape and tape that up. just sort of tape that over here so it doesn't keep flopping down in our way. So what do we got in here? So we've got an SN7405. So that's a hex inverter. LD110, LD111. Okay, so the LD110 and LD111 are two chips that work together by the look of it, that are a 3.5 digit analog to digital converter set. So I'm guessing that's going to be the brains of the operation. Okay, so it looks like this one down here is a 747 CP, which from a quick Google looks like a general purpose op amp. And there's another one over here. So just looking at the date codes for a bit of a reference here, we can see date codes are 74, 75, 75, 75, 74, 74. So it gives you a bit of an idea of the vintage of this thing. The 723 CJs, I'm pretty sure are voltage regulators, if I'm not mistaken. What else have we got going on? This would appear to be a bridge rectifier. What else is going on in here? Fuse down the back. Have a look in the front, see what's in the front. Interestingly, in the front, down in here, there's no screws in this board. It's just sort of floating in the breeze in here, so I'm thinking someone's been in here before us. That's the display board. There's our 3.5 digits. And we've got an SN7447, which I think is a BCD to 7-segment display driver, because I've come across those before. So the $64 question, I guess, is our signal getting to the input of the analog to digital converter stages? And if it is, are they producing a suitable output for the display? Okay, so to check the input to the analog to digital converters, I've got my bench power supply here plugged into the input, and I've got it set to DC 20 volt range on the front panel. And I'm just looking at pin 15 of the LD111, which is the input pin. And I'm currently getting pretty much 0, but I've got 0 volts coming in from the bench supply. If I wind that up, then yeah, as the voltage goes up, the input to the analog to digital converter increases as well, until we get to pretty much the top of the range. So we're at 20 volts there, and 1.7 is what's going into the A to D converter, and I'm pretty sure it tops out at 2 volts on its input. So it appears that we're getting an input signal on the LD111, but we're still stuck, probably can't see it, but we're still stuck at this 0.82 on the display. So that suggests to me that possibly the analog to digital converter chipset, one of these chips is not working properly, or maybe our display driver is cooked and is stuck displaying a single value. So we'll just have a look at what's coming out of the LD110 on the BCD outputs. And they are on pins 13, 14, 15 and 16. So pin, God, if I can stay on it, pin 16 is nothing. Pin 15 is something, but it's pretty constant. And that's pin 14, which is nothing, and pin 13, which again is pretty constant. So I'm leaning towards saying that this LD110 is not outputting particularly valid BCD. It's like its output is stuck. Let's just see what the digit strobes are doing. The digit strobes are on pins 1 to 4. So pin 1. Yep, we have a digit strobe there. And 2, yes. And 3, yes. And 4, yes. So the digit strobes are working, it's just the BCD output appears to be not working. So I think at this stage, I'm probably going to try and track down probably both of those ICs, probably the LD111 and the 110. I think the 110 is probably the guilty party here, but I'll probably track them both down since they sort of come as a set. That's going to take a week or two, so yeah, through the magic of editing, you will see me again when it's arrived. And just like that, the replacement LD111 and the LD110 have arrived. The LD111, that came from a reputable local supplier, but they didn't have the LD110. And the LD110s came from eBay, from a Chinese seller, so it remains to be seen if they're legit chips or whether they're full of Chinesium, but yeah, we'll see. So I'll probably replace the LD110 first, since it's the chip that's most likely to be legit, and we'll see how we go. I'm thinking it's probably going to be the 110, but I thought I'll start with the 111 first, and we'll see how we go. So yeah, have to desolder it. So I'll just add some fresh solder to help the desoldering process along. Now, this should be fun because when they manufactured this, they bent over the pins on both ends. Find a little screwdriver. Right, let's got them back up, so hopefully now we can desolder them. Yep, there's almost no pressure there, and it's out. Just give the board a bit of a clean up. Ooh, I've taken a pad off there. Just put a little bodge in that in a minute. Okay, new chip is in. Let's just solder him in. Looks like we've got another damaged pad down here. Right, what can we get that one? This one here we're going to need to do some work on. Bend it over. Good. Soldered. Okay, so new chips in down there. moment of truth. Let's turn it on and see if that fixed it, or whether I've got to replace the LD110 as well. Oh wow, you probably can't see that. It's not stuck on 0.82 anymore. So that makes me think that it wasn't so much the LD110 wasn't producing valid BCD, it was that the 111 wasn't putting valid data through to the 110. I wonder if this thing copped a massive over voltage or over something on its input at some point and literally popped the input on that 110. Interesting. I'll hook the bench power supply up and we'll try feeding it some voltage and see how well it works. So I've just turned off the camera lights so that you can see the display a little bit better. My bench power supply is feeding that 6.9 volts and it's showing 7.05, so it's a little bit out, but let's just wind the voltage down. Bench supply is at 5 volts. Getting 5.15. Now I don't know whether it's the bench supply is out or this multimeter's out, but what I can do is put the fluke in here. So 5.06 volts on the fluke, 5.15 on the DL703. We'll go down to say 1 volt. Yeah, that's a little bit out. Now we'll go up to 19 volts, 19.35, so the fluke's saying it's a little bit under, and the 703 is saying it's a little bit over. But it's ballpark. Unfortunately, I don't have the equipment to properly calibrate it. All I can do is try tweaking the adjustments to make it match, say, my fluke, which itself, it was probably calibrated when it came out of the factory, but that was, I don't know, 30, 40 years ago. It's a pretty old meter. And I don't have any reference sources to calibrate against. So, yeah, anyway, I'll put the display back in and start putting it back together, and then we'll see what we can do to get it adjusted just a little bit closer than what it currently is. Oops, I forgot to hit record, but I do have, if I can, yeah, I do have now some screws up here in the display to hold it in. So at least now that's sitting straight. Now we should be able to put this board back in here. I've just got to find the screws. It's these two. And that one. Right, and those are in, and these four are case screws. Okay, so I'm set up here now. I've got my bench power supply feeding into the front of the DL703, and I've got my fluke connected up to it as well. This is by no means scientific. I don't know how accurate the fluke is. I've got losses in the test leads. The test leads aren't the same length and not the same wire. I mean, it's not going to be an exact science, so it's just going to be good enough. So I'll adjust the 20 volt range because that's what we're on. The fluke says 1.053. Says 1.05. Just wind the voltage up a little bit to say 19 volts. So the bench supply is set to 19, the fluke's reading exactly 19. And we could probably go up just a fraction on the, there we go, on the 703. So I go back to 1 volt. .0, 1.06 on the fluke, 1.06 on the 703. So the 20 volt range is fairly accurate. The 200 volt range is going to be hard to do because my bench supply doesn't, I think my bench supply tops out at 30 volts or something. Yeah, 31.5 is full tilt. So the Fluke's reading 31.49. What do we got here? 32.2. So just one. That was kind of stuck. We have 31.5. Nope, that's as low as she goes. So that's adjusted all the way down. So just drop the voltage, say to 20 volts. Volts, 19.96 and 20 on here, so that's okay-ish. The 1000 volt range, I don't have anything that can push a voltage like that. About the best I could do is go to the 1000 volt range and wind up to say 30 volts and just see if it comes up with 30 on the screen. 30 and 30, so it's accurate to sort of to the volt. So what do we got next? Like the resistance, I suppose I could do the AC 350. Well, I know where I can get 240 volts from. Then we got resistance, so we'll do resistance next. Okay, so let's flip it over to the ohms range. You what now? 7.01. Why is it stuck? Let's just put a resistor across the input. So I've just got a 10k resistor I'm going to put across the input, which is just that one there. And we're still getting 7. Okay. That's a bit strange. So it looks like we've clearly got another fault here somewhere. So I had another Google around and I actually managed to find a schematic for this DL703. It was on radiomuseum.org, so I had to register to be able to download it, but hey, at least I got it. So just looking at this, we have a different reference voltage gets used for the ohms range, and that comes out of this combination of op amps here. Goes through our selector switch, and we basically have the reference voltage come back into pin 10 of our LD111. So it'll be interesting to have a look at the voltage at pin 10 of the LD111 and see what we've got there, see if we have our reference voltage, and I suppose have a look at the output of this this op amp and see what we're getting up there as well. Okay, so getting access to check that, of course, meant taking our board back out again, but anyway, you get that on the big jobs. And we've got, trying to see in there, need more light. I must fix my magnifier light. So 7, 8, 9, 10. So it's that pin there on the op amp. We're getting a steady 4.57 volts out of there. And what pin was it on our LD111? On our LD111, it was also pin 10. These chips are, this is around the other way on this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You what now? So we had 4 point something volts coming out of the op amp, and we're getting, well, a variable voltage around 0.1 volts at the LD111. That doesn't sound right. Let's just, I'm going to stick the scope on that just for giggles. Okay, so I got the scope hooked up, and our yellow channel, channel 1, is reading the output from the op amp, which is about what we saw on the meter, well, 4.7, 4.8 volts. And then for some reason, what we're getting at the LD111 on pin 10 is just some noisy mess. Yeah, that doesn't look like what we're after. So in the ohms range, the output of that op amp goes through the function selector switch and goes directly into the LD110. So it would appear I have a continuity issue somewhere between the op amp and the LD111. So it could be a circuit board issue, it could be a selector switch issue. Let's go digging. Alright, so I've got it back upside down again. Let's have a look. So this is our op amp IC over here, and this is our LD111. Right, so pin 8, 9, 10. 10 is that one. If I can stay on it. We'll go down to our ref in. Right, so we've got continuity to there. Now this is 1, 8, 9, 10. So that's 10 there. Oh, I can't stay. We'll go down here. And that's, where was I? 8, 9, 10. Need better probes. And that's open circuit. What is this mess? 8, 9, 10. Goes up to here. So continuity to there. And what goes on? Is that joined? Is that joined over there? It kind of looks like it is. Yeah, I think it is. Okay. Maybe it's not. Oh, I need sharper probes is what I need. Oh, hang on. See that? Ha! Yeah, that shouldn't be doing that. So it seems we have a problem here. Something's broken in this general area. So we'll just hook that solder off there so we can see what we're dealing with underneath. Oh, hot. Not coming off there very well. We'll fire up the desoldering gun. We won't desolder it, but we'll just use that to remove the solder. Okie dokie, let's just remove some solder. We can see what we're dealing with. That's, I think the trace is broken just here. Yep. So this has probably been pushed hard through the board at some point, broken that track. So we might need to sort of bodge a little bit of wire across there, I'm thinking. Go around the other side of that. Keeps it away from the other track there. Right. Let's see if that's made a suitable difference. Plug it back in, turn it on. Oh, that's looking a little bit, wow, actually, oh no, sorry, it does say 10.067 and I do have a 10k resistor across it, so that would be about right. We've still gone back to this sort of 7k though with the output completely open, so it's a bit strange. So maybe that's how it represents a an open, is just with seemingly a random display. Okay, well, let's quickly, I'll just turn this off and drop this board back where it's supposed to be. Now, unfortunately, I can't really calibrate, not that I could really calibrate the resistance range anyway, any better than I could calibrate the voltage range, because I don't have any calibrated references to do it against. But yeah, if you were paying attention earlier, you would have noticed that this variable resistor, this little trim pot, is missing his wiper, which is sitting there. That came off, yes, yeah, or when I was last working on this anyway, when we were doing the voltage calibrations. Yeah, I noticed that was adrift. So I'm going to have to order another one in. It's a 500 ohm trim pot. I don't have any 500 ohm trim pots handy, so I'll have to order one in. But yeah, I think we've probably resolved the issues with this particular multimeter, other than that trim pot that I'll have to replace. So yeah, well, I'll probably put it back together, and I'll put the case back on, and that'll probably be it for the video side of this repair. I mean, there's nothing really exciting to see replacing a trim pot, unless of course there is something exciting to see, in which case I guess there'd be a part 2. So anyway, let's put it back together. Okay, so we got the bottom of the case. I believe that just sits there like that. And then the top of the case, I think, goes that way. And we've got some screws to put back in, but not with that screwdriver. So that brings us to the end of the quick repair of the DL703. Yeah, a faulty LD111 chip and a broken trace on the board appear to be the main culprits for this one. I will have to get that 500 ohm trim pot but it'll be probably several weeks to a month or more before I get that, because a trim pot's like an 80-cent item, and it's not worth paying $15 in postage to get an 80-cent item. So I'll add it to the list of things that I need to order, and next time I place an order with my usual supplier, I'll add the trim pot to it, and yeah, I'll quickly just pop the lid and replace that. Yeah, so anyway, if you enjoyed this, feel free to tap like. It's a free thing to do, and it really helps. And if you want to subscribe, feel free to do that too. And yeah, until next time, cheers.